Newton's second law states that the acceleration of an object is directly proportional to the unbalanced force acting on it and inversely proportional to the object's mass. The direction of the acceleration is the same as the direction of the unbalanced force. When a kicker goes to make a field goal in football, the laws of physics come into play. The impact of the force of the kicker's leg on the ball is directly proportional to the acceleration of the ball multiplied by the ball's mass. Now that you know all about Newton's second law, let's see that clip again. Newton's first law states that in the absence of an unbalanced force, an object at rest remains at rest, and an object already in motion remains in motion with a constant speed in a straight line path. In football, we see an unbalanced force when a player tackles another player. When a quarterback catches a snap and a defensive lineman breaks through and sacks him, the quarterback is no longer at rest and is now moving in the direction the lineman has pushed him. The lineman has a higher inertia due to his higher mass than the quarterback, thus it will be harder for the quarterback to break this tackle and easier for the lineman to make the tackle, as inertia is the resistance of any physical object to change in its state of motion or rest. Newton's first law is illustrated in the clip we saw here.
Whoa! Watch out, man! Boom. Newton's third law states that for every action there is an equal and opposite reaction. In football, tackles beautifully illustrate this final law of motion. When a player hits another player, they both push on each other with equal and opposite forces. The conservation of momentum is also illustrated by tackles in these inelastic collisions. During these collisions, kinetic energy is released in the form of compression, and the sound waves the energy of motion is transferred to. The momentum of the players, their mass multiplied by their velocity, is the same before and after the collision. P before equals P after, proving the conservation of momentum during these collisions illustrated by Newton's third law.